Alright, so let's do some matching. Let's look at a graph and let's talk about matching. First of all, we're looking just at this right up here. That's what we're doing right now. We're just trying to match those 6 problems with the 6 graphs below. So the first thing we have to do is we have to recognize what the base graph is, and that's going to be this one right here. I'll do this one in red. That's your base graph. And remember that your base logarithmic graph is going to be the inverse of your exponential graph. So here is 3 to the x. So if I take the line y equals x and I flip it, that's going to be your graph. In fact, so that's right here, it's f. And you can even see when x equals 1, the log base 3 of 1, 3 to what power equals 1? The answer is 0. And that's why that point is 1 comma 0. This point right here, 3, that right there, when x is 3, log base 3 of 3 equals what? 3 to what power equals 3? 1. And that's why this point right here is 3 comma 1. Alright, so there's our base graph. Let me go ahead and erase. Whoops. Let me erase this off here. And now let's use that base graph and let's transform that graph to find our other graphs. So now let's do, well, let me go ahead and circle this so we know that we've already chosen F. Alright, now let's do in blue. Let's do this one in blue, number 2. So what did I do to that graph? Subtracting 1 from the inside of x. If you remember with transformations, that moves it 1 to the left. So my new asymptote, instead of my vertical asymptote being here, I'm sorry, to the right, it moves it 1 to the right. My new asymptote is going to be right here. And so you can see that letter E has got that asymptote, but that's the only one. So E is your answer, because you moved everything, including the asymptote, 1 to the right. This next problem, let's do this in orange. Now I'm subtracting 1 on the outside of it. So it's kind of like I'm subtracting 1 from the y, and so that moves it down 1. So this graph right here, remember this was our base graph. What if I moved every point down 1? Is it going to affect my vertical asymptote?
No.
No, it's not. What's it going to affect? It's going to affect each one of these points is just going to move down 1. So all these points are going to be 1 lower than what they were before. But your asymptote's going to be the same. So it's going to look pretty similar to that graph F, but it's going to be just shifted down 1. And can you see what that one is? That's C right there. So number 3 is C. Now number 4, notice what number 4 does. I'll do this in purple. Number 4, you've got a negative. You're taking and you're making the outside of it negative. I like to take the graph of x squared and use this as an example. So I like to take the basic quadratic graph and think, what happens if I make it negative? What happens if I make this negative on the outside? Notice I'm not making it negative on the inside with the x, but on the outside. And if you remember, this opens down. So the purple graph opened up, but the red graph will open down. So what does putting a negative in front of a log do to that? To this original graph right here? It makes it open. It flips it, rather. It flips it over the x-axis. That's what it did, because your original graph would have looked like this. And making a negative right there flips it over the x-axis. So how do I flip this over the x-axis? Let me erase this so you can see flipping that over the x-axis would make this point would stay the same on the x-axis, and everything else would do this. So which one of those graphs is that graph?
D.
D is that graph. Number 5, this is one of my favorite ones to talk about. For number 5, Notice how there's a negative on the inside. Well, what if I made that x, that negative on the inside, that typical x squared graph? Does squaring a negative do anything? What happens when I square negative x? It still equals x squared. So what did I do essentially to this purple graph here? I just flipped it over the y-axis. And it doesn't look any different when I flip it over the y-axis because it's symmetric to the y-axis. So that's what I want to do with this graph right here. I want to flip this graph over, that graph right there, I want to flip over the y-axis, over this axis. So every point goes to the other side. And which graph is that? That's B. And then number 6 is the hardest one, but fortunately we only have one left, so we know what the right answer is. See, I'm running out of colors. I'll do this in pink. So number 6 right there. This is what I like to do. I like to take your base graph, but now my base graph is going to be the negative log base 3 of x. So remember that one, that was the purple one. So this is my base graph right here. And now I'm going to do what? What does that 1 do to it? Is that inside or outside? That 1 is being added to the outside, right? And so adding to the outside does what to my entire graph?
Moves it to the left.
Nope. Adding to the outside. Adding to the inside moves it to the left, but I'm adding that to the outside. I'm adding that to the y value. It moves everything up. So this graph, whole graph, just shifted up, is right there. See how that's the same graph, but it's just shifted up? So that one's A. So that's sort of a long explanation for that, but I wanted you to understand the process, the thought process behind translating graphs and understanding how that works.